Today on the John Ankerberg Show, we are examining the evidence from astronomy that points to an all-powerful creator. On April 24th, 1992, newspapers around the world heralded the breakthrough news that the COBE satellite gave scientists convincing proof that the cosmic background radiation of the universe proved that the Big Bang model of the universe was true. Theoretical physicist Stephen Hawking, known for understatement, said, "It is the discovery of the century, if not of all time." Ted Koppel on ABC's Nightline began his interview of a physicist by quoting from Genesis 1 the words, "In the beginning, God created the heavens and the earth." What was all the fuss about? My guest who will tell us is astronomer and astrophysicist Dr. Hugh Ross, who obtained his Bachelor of Science degree in physics from the University of British Columbia, his PhD in astronomy from the University of Toronto, and for 5 years was on the faculty at Caltech. We invite you to join us for this special edition of the John Ankerberg Show. Welcome to our program. I'm John Ankerberg, and my guest today is a very special guest. He's astronomer and astrophysicist, Dr. Hugh Ross. Hugh obtained his Bachelor of Science degree in physics from the University of British Columbia and his PhD in astronomy from the University of Toronto. Then for 5 years, he joined the staff at Caltech and did postdoctoral research on quasars. And then along the way, he established his own ministry called Reasons to Believe, which is a terrific ministry and has written tremendous books. One of them that we're offering to you, The Creator and the Cosmos, which is full of science and why science, actually, he was a non-Christian when he was a young man, and the science led him to become a believer. Okay, it wasn't the Bible verses, it was the science that he looked at. As an astronomer, astrophysicist, it was that which led him to become a Christian, and maybe he'll tell the story as we go along. But today I want to start with a discovery that came out April 24th, 1992. The newspapers around the world were loaded with this because an American research team made a discovery that made the front pages of all the newspapers. American television networks gave it 40 minutes for like 5 nights in a row, and it had to do with the COBE satellite and what they had found concerning the hot Big Bang creation event via the COBE satellite. Explain what all that means, Hugh.
Well, the early measurements on the universe, attempts to measure the temperature of the universe, they determined it had exactly the right temperature that the Big Bang creation model would predict. However, that Big Bang creation model also predicted that if you were to measure the temperature of the cosmic microwave background radiation to a high degree of precision, you will see hot spots interspersed with cold spots, where the hot and cold spots are a certain angular size.
Which you need.
Yeah. The first attempts to look at that, they couldn't find it. Everything was homogeneous and uniform. The COBE satellite was the first instrument that was sensitive enough to really put the Big Bang creation model to the test. And I remember at that time, astronomers around the world were sitting on their seats in anticipation. Is the Big Bang going to be proven right or proven wrong? The initial results came back, and indeed, they found the temperature fluctuations of just the right level with just the right angular dimensions. And so that got publicized all around the world, convincing proof of this Big Bang.
Yeah, we could actually go before that there were people that did research that led up to figuring out that there was such a thing as the Big Bang. Give me a few of them.
Well, Vesto Slipher back in 1912 was the first astronomer to discover that the more distant the galaxy, the faster it moves away from us. And he was followed by Edwin Hubble. He used the world's largest telescope at that time.
100-inch.
100-inch telescope just above Los Angeles. And he was able to measure several dozen galaxies to much higher precision than what Slipher was able to do. And he published in 1929 a paper which said, here are the observations proving that the universe indeed is expanding. The farther away the galaxy, the faster it moves away from us. The only possible explanation, the universe is experiencing a general expansion. But that's something that actually flowed out of the equations of general relativity that Einstein published back in 1916. And it was a Belgian astronomer, actually a priest, Georges Lemaitre, who took those equations of general relativity and said, this establishes not only does the universe have a beginning, it must be expanding from the beginning.
Yeah, I want to come back to Einstein in just a moment, but there's something else we need to tell the people, that when they looked through their telescopes, they found that there was a prism of color. Tell them what the colors meant to them, how they found this out, that the galaxies were rolling away from us or coming closer to us.
Well, they used a prism in order to see the spectral lines that were being emitted or absorbed by these distant galaxies. And what they noticed is that these spectral lines were being shifted to the red end of the spectrum. That's the Doppler effect. So, for example, when a train goes by a train station, you notice you hear a high-frequency sound as it approaches, a lower-frequency sound as it moves away. That's the Doppler effect. And we saw the same thing in the spectra of these galaxies, indicating that indeed, the more distant the galaxy, the farther towards the red end of the spectrum the spectral lines were shifted, again indicating the universe is experiencing a general expansion as predicted by Einstein's equations of general relativity.
Yeah, I'm going to come back to Einstein again, but I want to talk about what is the cosmological constant?
The cosmological constant is something that Einstein put into his equations to eliminate the expansion. Because after all, he was raised in an era of what's called the infinite Newtonian universe.
And he wanted it that way.
And so he wanted to be consistent with that. But in order to get rid of the expansion that his equations predicted, he put in an additional term that counterbalanced the expansion so that the universe would be stable, not expanding, not contracting.
Another way of saying it was actually in changing or fiddling with his figures, he showed a bias. All right? And what was that bias?
Well, again, the predominant cosmological worldview at that time was the universe is static. And so he said, my equations don't fit that. What can I do to adjust the equations to sustain the static universe model?
And if the universe is static, what does that mean? What does that do for the non-Christian scientists that are out there?
Well, today we know a static universe is a universe that would not permit the existence of life. But back at the beginning of the 20th century, that was not yet understood.
They thought that evolution could have enough time to slowly develop and...
Well, that was something that Einstein's friend, the famous British mathematical physicist Sir Arthur Eddington said. He said if it's according to Einstein's theory of general relativity and according to what Hubble has measured for the expansion of the universe, that only allows the universe to be a few billion years old. And a few billion is not enough time to sustain Darwinian evolution. And that's when there is a major debate going on amongst astronomers. Is the universe quadrillions of years old or only billions of years old? And today we know the young universe astronomers won out. It's only billions, it's not quadrillions.
Yeah, but they made both sides of certain people mad because they wanted a universe that was infinite.
Well, whatever illusions the biologists had, the astronomers knew if we're only talking 10 to 20 billion years, that's way too little time for naturalistic evolution to be a viable explanation for the history of life.
Yeah, and it also affected the Christian world as well. Talk about that.
Well, there were some Christians who believed that the creation days in Genesis 1 were 6 consecutive 24-hour periods. And it said if that's the case, we're looking at a universe that's thousands of years old, The Big Bang is telling us it's billions. And so, yeah, the atheists were upset because it made the universe too young, and younger creationists were upset because it made the universe too old.
Yeah, let's go back to Einstein. What is general relativity and what is special relativity?
Well, in 1905, he came up with his theory of special relativity, which is explaining the dynamics of the universe where you only look at the velocities of the different objects in the universe.
Light.
Light in particular.
Which is constant in terms of speed.
Velocity of light is constant. But it was in 1916, he said, I'm not only going to look at the velocities, I'm going to look at the accelerations. And special relativity is not that intellectually challenging, but general relativity is extraordinarily intellectually challenging. It took the genius of Einstein to come up with general relativity. And it explained not only the velocities, but the accelerations of all the bodies in the universe. And what was remarkable, Einstein, in developing his theory, said, here are 3 specific ways you can put my theory to the test. These are the observations that, if successful, prove my theory, if not, disprove my theory. And within a few years after he published it, astronomers were able to put his theory to the test, and it passed with flying colors.
Yeah, but it also led him to a conclusion that he didn't like. What was it?
Well, the conclusion he didn't like was that if his theory of general relativity is true, the universe has a beginning. It's not infinitely old. And that's why he threw in this extra term in his equations. But when he looked through the telescope on Mount Wilson with Edwin Hubble, he recognized, you know what, the way I produced my general relativity originally, that's the correct formulation.
He fiddled with his own math to make it come out the way he wanted. He had it correct the first time,
right,
but then he fiddled with it so that it would come out to be an infinite universe. And it was Hubble that said, I want you to come on over here and look through my telescope, and I want to show you that the galaxies are moving away.
Yes.
And what happened?
Well, he looked at his paper, he looked through the telescope and said, you know, that fudge factor I put into my equations, it's the greatest blunder in my scientific career. And that was picked up by newspapers around the world. But here's the irony, John. Today we're reviving his cosmological constant. He had the wrong value and the wrong sign, but today we're actually appealing to his cosmological constant to explain a feature that astronomers have seen that Hubble did not see. It's not just that the universe is expanding, the expansion rate is accelerating. So we revived his cosmological constant, but different sign, different value.
Yeah, let's jump to another person that everybody knows, and that's Stephen Hawking. He took general relativity and special relativity, and he did something with that, and talked to us about his research and what he came up with.
Well, he had some help. George Ellis in South Africa and Roger Penrose at Cambridge and Stephen at Cambridge worked together over several years, taking those equations of general relativity and saying, what does that tell us about the history of the universe, and particularly the beginning of the universe? And it was in 1970 that Roger Penrose and Stephen Hawking published the first of the space-time theorems of general relativity. And the power of those theorems, they're based on 2 fundamental assumptions. Number 1, that the universe contains mass. And both of us are living proof that the universe contains mass.
Right.
So that's rather trivial. The second assumption, general relativity reliably describes the movements of bodies in the universe. Today we know that's correct to 15 places of the decimal. And so that's been established. And what Penrose and Hawking said, if those 2 things are correct, not only does the universe have a beginning, even space and time have a beginning. Space and time must be created.
Yeah. Now, why was it that Einstein didn't include time and space with his theory?
Well, he did. I mean, it is a theory of space and time and gravity. All that was in there. What Hawking and Penrose and George Ellis did is they simply applied what he had done, what he started. and said, let's see what else we can get out of this general relativity. And we've gotten a lot more since Hawking and Penrose about what general relativity predicts. We now have a good understanding of the physics of black holes. They didn't even conceive of black holes at that time. And so there's been a lot more development of general relativity since the time of Einstein.
He came up with a singularity as the beginning. What is a singularity? And talk about the ingredients that, when he went back to the beginning, how he defined a singularity.
Well, lay people tend to define a singularity as when all the matter and energy gets compressed to a single point. A more accurate reference is it's when the entire universe gets compressed into an infinitesimally small volume. And that volume actually has 10 space-time dimensions. So think of something that's very squished together. That's the beginning of the universe. Space and time were created, 10 space-time dimensions, and it's expanding. And it's the release of space curvature. So as the curvature is released as the universe expands, that very quickly produces photons. The universe actually starts off dark, but by the time the universe is a trillionth of a trillionth of a trillionth of a second old, there's photons throughout the universe. And later, we get the particles that are responsible for the matter.
Now, the new atheists, as they're called, have tried to come out with mathematical theorems that would explain how, from a singularity, you could get another universe. One of them had to be like our Earth, okay? But talk about how they were trying to do this. In other words, what was their hope?
Well, there's two directions that they went. One direction was to say, well, the space-time theorems presume that general relativity describes the movements of all the massive particles in the universe. And they said, well, what about before matter exists? What about that very early era, the first 10 millionth of a trillionth of a trillionth of a trillionth of a second? That's when we'd expect quantum mechanics to play a significant role in governing the dynamics of the universe. Maybe quantum gravity actually permits a loophole where we don't have a beginning to the universe. So there's lots of papers being published in the scientific literature today.
Is it true that when you get far enough in, that quantum cosmology basically says that Einstein's theories about gravity, okay, all of a sudden don't operate the same way?
No, they're saying his theories of gravity do operate, but they said they're complemented by the impact that quantum mechanics has at that extremely early era, and that the quantum mechanics may actually allow for a loophole. However, for that loophole to be valid, the quantum space-time fluctuations during that era have to be quite large. And astronomers recently have made measurements of the images of distant quasars, because as the light travels from these distant quasars, the inherent quantum space-time fluctuations get magnified. They actually predict that the images will become blurry after they go through a lot of space travel, also in proportion to the wavelength of the light. So far, astronomers have only seen sharp images of these distant quasars and blazars, which means the quantum space-time fluctuations can't be large. So it's sustaining the space-time theorems. Now, we haven't explored the entirety of the quantum gravity era. As many physicists have pointed out, to get a complete picture, we need a particle accelerator from here to the most distant quasar, which is not going to be financed anytime soon. So,
what does that tell you about how the God of the Bible, the creator of the universe, was the great designer? Are they able to tell the differences yet in what they need and what they don't have?
What I'm seeing happening amongst my peers is that 100% of the observational and experimental measurements that we can make on the universe, 100% of it testifies there must be a God that created the universe and designed the universe and all of its components so that we humans can exist. What I see the atheists doing is they're appealing to things that we can't know, to those parts of the universe we're not able to explore or make any measurements. And they're speculating based on what we don't know, maybe there's some escape hatch. The very fact that they're forced to appeal to non-empirical arguments for their atheism tells me how weak their atheistic position must be. And also, as we astronomers begin to press back on the frontiers of ignorance, as we push back, it's revealing more and more evidence for the God of the Bible. The atheists are being pushed into a smaller and smaller corner of speculation about what we don't know.
Yeah, when I first read some of this stuff, it seemed to me like we have the universe that we're in, and everything that you can measure and look at here points toward a creator.
Exactly.
And what they're doing is they're doing mathematical equations on paper of what they think it ought to be, but it doesn't realistically have anything to show for it. There's nothing that they can say, this is what actually came out of that.
Well, I see an inconsistency. Everywhere else in their life, they base their decisions on reality and what they can see and measure and do experiments on. Only in this region about God are they appealing to things that we can't say are real. And moreover, their speculative room is shrinking down smaller and smaller. That should tell you something, that you're on the wrong path, you got the wrong model.
Yeah, at the end of this series, we're going to talk about some of your friends, basically, that have made statements to that effect, that what they've noticed in all of their research is that you have to come to the conclusion that there's a designer out there. But for the person that right now that is struggling with this, that doesn't know all that you know or what you've been talking about, what would you say about, in the meantime, of putting their faith, or at least leaning toward the God of the creator of the universe that we are in?
Well, there's a principle you see described in the Psalms and the book of Job, that the more we learn about nature, the more evidence we'll uncover for the supernatural handiwork of God. You know, I put out a weekly blog called Today's New Reason to Believe, and it's based on the fact that I go through the scientific literature. Every day, there are new discoveries being published that give us more evidence, not less, for the supernatural handiwork of God. I tell my friends who are still skeptical, wait 1 week and see what gets published.
Yeah, we're going to put Hugh's website and his blog on our jashow.org website, and we encourage you to go there. I want to say thank you for joining us. I hope this has been informative to you, and I appreciate your being with us, and I'd like you to just stay tuned because I have a personal word for you in just a moment.
For additional resources or to view our TV program, log on to jashow.org. That's jashow.org.